Okay, welcome everyone. Welcome to the afternoon session of this symposium in the history for physics. And for the contributed talks, the first talk will be by Agne Alijauskaite, visiting from the University of Vilnius. So, the stage is all yours.
Thank you very much. Actually, I'm not a physicist and I'm not a historian of science. I'm a philosopher. That's why I asked the organizers after the acceptance if they really are interested in my talk. But since they confirmed that, well, then you need to listen to this talk. So first of all, Eddington's approach to quantum theory challenges physics as a description of the world. Since this description is, in a sense, predetermined to be seen as complete and sufficient, the questioning of its completeness is perceived as a threat to an ideal project. This is one of the reasons why Eddington's theorizing is seen as too unorthodox when discussing foundational questions in physics. However, quantum theory discloses such variations of incompleteness as quantum indeterminacy. The principle of indeterminacy is firstly epistemological in the sense that it reminds us that construction of the physical world out of knowable is an ideal, which can hardly be achieved. If until the emergence of quantum physics, a physical system was defined by having a determinate state which is determined by measurable properties, and vice versa. After the emergence of quantum theory, the description of a system became necessarily incomplete. This incompleteness means an epistemic shift marked by quantum indeterminacy. The vision of a presumably complete system of knowledge became blurred and unreliable. It was followed by the quantum necessity of incompleteness, which guaranteed the place for a subject as a legitimate creator of physical reality. This is why an epistemological approach to quantum mechanics is primarily idealist or subjectivist. According to Schrödinger, Eddington's epistemology argues that the structure of the objective world is precisely represented within the consciousness of the observer, such that a quantitative convergence of discrete values between essential properties of the universe and the conditions of the human brain associated with consciousness would be required. This means that the worldview that we perceive as a physical one is constructed in our consciousness from received signals. The so-called objective world is beyond the accessibility of the mind. That is why the complete view of the physical world is epistemically unavailable. If by agreeing with Eddington, we would argue that the world is constructed from messages spread along nerves, physiologically the process would look like if, as already noted by Messenger, action potentials of a neuron are the essential units of thought and awareness, while the RNA sequences are the initial physical substrate for the representation of experience. That is, memory and patterns of proteins expressed as spines on dendrites of neurons within the cerebral volume. So there is a continual interaction between action potentials or thoughts and a physical substrate. This is Eddington's idealism as much as quantum neurophysics. Not only Eddington, but also Bohr decades earlier suggested that there was a possibility of interaction between thought and matter by energy determining the essential features of thinking at quantum levels. Thinking and the finding of matter are interactive parts of the same process, which is the process of creation at quantum levels. The unanswered question here is how far can this process lead, or in other words, what level of creation functions in the quantum realm. The unsolved problem is the cognitive structure of the world. Eddington saw the possibility that understanding of the ratio of mass between protons and electrons might lead to the understanding of the cognitive structure. As seen from this point of view, the number of protons in the universe serves as proof of certain cognitive construction that lets us approach the world in an epistemically fruitful way. This means that Eddington's epistemology bridges the gap between properties of consciousness and the properties of the universe. This is why the possibility that thought is able to affect the universe was being considered in serious terms. Philosophical idealism here is a necessary condition because we have such examples as the measurement of a photon changing the polarity of the paired photon ions before the present. So the acknowledgement of the possibility that thought or observation can affect the universe by affecting the process of change leads to the recognition of the epistemic incompleteness. The physical world cannot be fully known because it is in constant change, as we know from the history of ancient cosmology. The knowledgeability of this world is even more complicated when the act of observation itself makes a change. So the process of observation or the cerebral activity is the final reference point of measurements for astrophysical phenomena. This activity defines the relation between the potential and the actual. In Eddington's view, if there is potential energy, there is also potential matter. This would be consistent with his assumption that particles display duality in which they exist continuously to contribute to the structure of the universe, while the other condition is a value that may not exist at any given time. The wave-particle duality is what makes Eddington's question, that is, if there is potential energy, there is also potential matter, eligible. The epistemic enigma here is what role does an observer play in the process of potential becoming actual. To make things even more complicated, the question can be reformulated by asking what is the role of an observation instead of an observer in this process. So, the process of observation and observability itself are central ideas in Eddington's epistemology. From here comes the notion of a priori knowledge, which is grounded on the knowledge gained through the process itself. What is the difference between a priori and a posteriori for Eddington? As noted by Rickles, a priori epistemological or a priori knowledge is prior to the carrying out of observations, but not prior to the development of a plan of observation, a posteriori result of observation or measurement. As we can see, Eddington does not deny a posteriori knowledge as such, but rather sees it as consequent from observation. A priori knowledge, on the other hand, is seen as epistemological and being prior to the observation. The most complicated part here is the claim that a priori knowledge is not prior to the development of a plan of observation. My guess would be that this means that by planning an observation, an observer gains certain epistemic knowledge simply by theorizing the plan. Eddington acknowledges the importance of the theoretical look at the carefully prepared steps of the way the things are going to be seen. This knowledge is prior to the empirical knowledge gained through the observation itself. By observing the necessary conditions demanded by the construction of observables, Eddington's scientist gains the a priori knowledge. Following Rickles, we claim that the subject of Eddington's project is scientific observation itself, and the discoveries encoded in the most general laws are really discoveries about the processes of measurement and observation. In other words, there is nothing left outside the processes of measurement and observation. The process itself becomes the central issue when answering the question of what can we know about the most general laws, because observation is all that can be known. Such a claim is a challenge to science in general because it questions the image of objectivity. The processes of observation and measurement are dependent on the observer, so they are subjective. However, the relation between subjectivity and objectivity in Eddington's thought is not entirely clear. Here we can stay with the widely discussed claim that his views were primarily influenced by his Quaker worldview and the value of inner seeking. In this case, the process of seeking is much more important than given truths, which are mistakenly seen as final answers. Since seeking is happening through the introspection, Eddington is often called an idealist, a quasi-idealist. or probably most famously, a selective subjectivist. We will borrow Durham's definition of selective subjectivism, which can be explained in terms that objective reality exists, but our knowledge of it is subjective. In this case, the objectivity as such is not denied, but an approach to it is subjective, as well as the process of observation. Since the process of observation is the main source of knowledge, all the domain of knowledge remains in a subjective realm. This is in line with Eddington's anti-dogmatism, which invites not to look for complete certainty because it leads to stagnation. Subjective scientific observation is an antidote to subjective certainty and is able to open new possibilities when looking from a particular observer's point of view. For Eddington, observation is the human mind selecting data from the four-dimensional universe. And going even further, the laws of physics were therefore created by human observation. This closed cycle of physics, in which the mind both creates and discovers natural laws, gave humanity and human experience a renewed place of importance. This means that physics was no longer an independent domain of objectivity, but rather a form of observation constructed by a human mind. However, Eddingtonian idealism, or more likely selective subjectivism, does not give the only answer, but rather refers to different kinds of epistemologies. The question then is, what kinds of epistemologies? According to Stanley, Eddington's entire epistemology of science is built on intersections of world lines and the interaction of the mind with the world. Observations are sets of signals passing along our nerves, and pointer readings are code messages that have no meaning without a conscious observer. How these sets of signals will be received and how these code messages will be understood depends entirely on a specific observer. A similar understanding is expressed by Hal J. Craig when discussing selective subjectivism. It is the mind which determines the nature and extent of what we think of, like the external world. We force the phenomena into forms that reflect the observer's intellectual equipment and the instrument he uses. In other words, only forms are available to our instruments, and these same forms are already forced into a certain image held in an observer's mind. Here we come to the three different kinds of subjectivism in Eddington's thought: personal, generic, and instrumental. The last one is proposed by Witt Hansen and requires a plan of observation. Here, instruments generate a selective effect. This is quite challenging because if an observation is determined by an instrument, then it is not really subjective. It is determined by circumstances that are outside of a subject. On the other hand, if we claim that it is still a subject who determines all the process of observation, including all the tools and how they are perceived, there is no such thing as instrumental subjectivism. Eddington explicitly discusses personal subjectivity. Summarized by Herab Martin, it hinges on the observer's position, speed, and acceleration, and may be corrected using the general theory of relativity in order to obtain a conception of the world from the point of view of no one in particular. So the personal subjectivity is said to be objectivized, at least to some degree, by comparing its results to the ones of the universal theories. The situation is different with the generic subjectivity. This one cannot be corrected, originates in the sensory and the intellectual equipments that generate the selective effect, selective subjectivism. So Eddington's selective subjectivism is grounded particularly on the generic subjectivity. We should ask here, what place does the personal and maybe even the instrumental take when looking through the lenses of selective subjectivism, which happens to be the main and probably the only lenses when looking from Eddington's point of view. I would go even further and ask if there is only one kind of epistemology to be discussed when studying Eddington's approach, if we can differentiate between instrumental, personal, and generic subjectivity, we can probably draw the line between different epistemic approaches. Since Eddington called the identical laws subjective laws or a priori laws because they were of epistemological origin, arising from the selective effect, we should consider different different kind of epistemology, which incorporates the knowledge from the outside, as in the case of personal subjectivity. In other words, what could guarantee that the epistemic knowledge cannot be corrected when, for example, seen as in a dialogue with other epistemologists' position? According to Jarab Martin, the epistemologist's task is to discover what empirical facts do not line up with our intellectual frame of thought. That is, which opinions are not analytic a priori, for we could not have this kind of a priori knowledge of laws governing an objective universe. For this task, the epistemologist must compare this a priori knowledge which he can acquire by investigating the instrumental, sensory, and intellectual equipment with the physicist's observed empirical data. Then any of the physicist's empirical data that do not line up with the epistemologist's a priori theoretical model are objective elements belonging to the external world. But what about 2 or 3 epistemologists who compare each other's data and get probably different results? Does it tell something about the external world? If yes, should not it be called, for example, a shared epistemology? And if not, isn't it even no longer idealism but solipsism? I think these are the questions in need of more comprehensive consideration when thinking about Eddington's epistemology and its kinds. Thank you very much.
Okay, questions?
Thank you for the talk. I wonder, I know you said you're not an historian, but I'm going to ask maybe an historical question. Do you have a sense for whether anyone at the time was engaging with Eddington's work in this area? I mean, we have a maybe unfair caricature I have in my mind, without having done serious work on it, that when he began working on these topics later in his career, it was seen by colleagues, as you've suggested, I think unfairly or prematurely, as somehow just he wasn't doing serious work, it wasn't coherent, and so you've been finding a kind of a coherence in the arguments from these later parts of his career. And I'm just wondering if you have a sense that were other people engaging with this work at the time, or was it really just ignored and it's now available for people today to go back to and ask questions in the light of cubism or other ideas about psi-epistemic? Do you have a sense of what do people make of it closer to his own time?
Well, as I guess most people who study the history of physics, even in a deeper level than me, know that Eddington's theory was looked at as too weird at that time and so on, so nobody really wanted to engage into that discussion. But as I promised in my abstract, to discuss the dialogue between him and Schrödinger, so Schrödinger would probably be that figure that engaged in a considerable discussion with Eddington. But I didn't discuss this because it would take too much time and it would be too broad in this case.
Eddington also had a particular view of relativity. How is this related to his view of quantum mechanics? Were there interpretational similarities? Eddington's view of general relativity.
Okay. I didn't do a decent research on this, so I would not try to answer it as a very at a very specified level. So I do have some understanding, but I don't really want to speculate at this time, so I won't do this.
It's just a quick comment about the reactions at the time. In the 1940s, when David Bohm was a graduate student at Caltech, not yet at Berkeley, he became very interested in Eddington's work and tried to begin to work on this. And he was strongly disencouraged by Thoma, who was then a professor at Caltech. So it's just a case, but illustrates a kind of how good physics teachers at the time saw Eddington's suggestions on quantum mechanics.
Okay.
Is there any
Thank you.
other question? I have a quick question. I'm not sure, like, when was Eddington proposing these ideas on interpretation of quantum mechanics?
Are you asking about a certain time? Oh.
Yeah.
Because since I'm not a historian, I certainly cannot to tell you the very certain dates. I cannot do that.
Okay.
I think there are people who could answer this question in a more qualified way. So
Okay.
I cannot tell certain dates.
Okay. Like the span of years, or like, okay. Because there were like similar. I was thinking of a book in the late 30s by London and Bauer called "The Theory of Observation in Quantum Mechanics,"
Yeah.
which expresses somewhat similar views. So I was curious if those similarities could be, time related, or if Eddington was influenced by them or them by him.
Yeah, your question is perfectly relevant in this context, and I was looking at all these biographical coincidences and so on, but it would take a different kind of work, a different kind of research to make all these connections clear. So it wasn't like my purpose at this time. So,
Okay, if there are no more questions, let's thank Agne again.
thank you.